Welcome to Funny EHS Info, a YouTube channel to learn about safety. Today we are going to know about the basics of fire.
What is fire? Fire is rapid, self-sustaining oxidation accompanied by the evolution of varying intensities of heat and light. This definition indicates that fire is a chemical process of decomposition in which the rapid oxidation of a fuel produces heat and light. This process makes fire the mid-range reaction based on the speed at which the two other common forms of oxidation occur. Rust or corrosion is an example of the slower form, and explosion is an example of the more rapid form. Types of fire. As far as safety is concerned, there are two types of fire. One, controlled safe fire. This is used in our daily life such as cooking, heating. Two, uncontrolled dangerous fire. There is no control on the size, duration, temperature, smoke and fumes of fire. This type of fire occurs due to the accidental or due to criminal act spread of fire to catch combustible materials. Stages of fire. The fire can exist in 4 different stages. The initial stage, incipient stage of fire, smoking stage, visible smoke. Flame stage, flame starts, smoke increases. Heat stage, uncontrollable heat, large amount of smoke. Elements of fire. 3 basic elements must be present for a fire to occur: fuel, heat, and oxygen. Fuel can be any combustible material in any state of matter, solid, liquid, or gas. Most solids and liquids become a vapor or gas before they will burn. Classes of fire. Fire is divided into 5 classes based primarily on the fuel that is burning. This classification system helps us assess hazards and determine the most effective type of extinguishing agent. It is also used for classifying, rating, and testing fire extinguishers. Class A fires involve ordinary combustible materials, wood, paper, and cloth. Class B fires involve flammable and combustible liquids and gases such as gasoline, fuel oil, and propane. Class C fires involve energized electrical equipment such as motors, appliances, and machinery. Class D fires involve combustible metals such as magnesium, titanium, and zirconium. Class K fires involve cooking oils. This is the newest of the fire classes. Extinguishing methods. All of the methods we use to control and extinguish fires are based on the fire triangle. We focus on removing one or more of the elements that allow the fire to continue. The most common extinguishing method is to remove the heat. This is usually done with water. The goal is to apply water to the burning materials in sufficient volume such that the water is absorbing more heat than the fire is generating. If this is done, the burning materials will be cooled enough to drop below their ignition temperature and the fire will go out. Breaking down the chemical reaction is probably the second most common extinguishing method. Dry chemical, halon, and some halon replacement extinguishing agents function this way. They inhibit the ability of the materials involved to sustain a chemical chain reaction. Removing the oxygen is also a relatively common method of extinguishment. Carbon dioxide agents work this way, as do simple techniques like putting a lid on a pan. They work because they remove oxygen. The last method, which is usually confined to special types of fires, is removing the fuel. One example is a fire involving a flammable gas. The ideal way to extinguish that kind of fire is to shut off the gas flow. Another example is the way most forest fires are controlled. A break created in the path of the fire removes the fuel and stops the fire's progress. Extinguishing agents. Water. Water is by far the most commonly used and readily available extinguishing agent. It is used in portable fire extinguishers, manual hose lines, installed systems, and as a base for foam water systems. Water works well because it has a large capacity for absorbing heat. As we mentioned earlier, absorbing the heat cools the burning material to below its ignition temperature, thus causing the fire to go out. Water absorbs the most heat during its conversion to steam. Carbon dioxide. Carbon dioxide is a gaseous fire control agent that is stored under pressure as a liquid. It is rated for Class B and C fires. The major advantages of carbon dioxide are that it leaves no residue and is non-conducting. It does not afford as much fire control capability as halon or some halon substitutes, but it is much less costly. It functions by excluding oxygen from the fire. Dry chemicals. Dry chemical agents are fine powders, about the consistency of talcum powder, that are based on several chemical compounds. They are available in two categories: regular dry chemical agents which may be used on Class B and C fires, and multipurpose dry chemical agents for use on Class A, B, and C fires. They both function primarily by interrupting the chemical chain reaction. The most common regular dry chemical agent is sodium bicarbonate, baking soda. The most common multipurpose dry chemical agent is monoammonium phosphate. A common dry chemical used primarily for protecting significant flammable liquid exposures is potassium bicarbonate. Wet chemicals. Wet chemical agents, typically potassium acetate, are designed specifically for cooking oil and grease fires. They are available in portable fire extinguishers and installed systems. Foam. Foam is a general category of extinguishing agents that includes a wide variety of specific foams for special purpose application. Foam is used in portable fire extinguishers, wheeled extinguishers, manual hose lines, fixed hose systems, and a variety of installed systems. Two major types of foam are chemical and mechanical. Chemical foams are created by a chemical reaction and are rarely used. Mechanical foams are created by mixing foam concentrate with a specific proportion of water to form a foam solution. Dry powder. Dry powder agents are designed to control fires in combustible metals, Class D. The two most common agents in this category are G1 and Metalex. Dry powders function by creating a crust over the surface of the burning metal. To extinguish the fire, this crust must completely cover the burning surface. These agents are usually applied by hand scoop or portable fire extinguisher. Graphite and sodium chloride are two common examples of these agents. Important definition. Some well-known acronyms with meaning to understand about the principles of fire. Flash point. The flash point is the temperature at which a liquid gives off sufficient vapors for an external ignition source to cause a flame to flash across the surface of the liquid. Fire point. The ignition temperature or fire point is the temperature at which the material will begin self-sustained combustion if an external ignition source is used to initiate the process. Auto ignition temperature. The autoignition temperature is the point at which the material has been sufficiently heated for combustion to occur without an external ignition source. UEL and LEL. The flammable or explosive range identifies the percentage mixture of flammable vapor or gas in air that can be ignited. The flammable range is the area between the upper and lower flammable limits, also referred to as explosive limits, UEL and LEL.
This is all about today's topic. Thanks for watching Funny EHS Info. And don't forget to subscribe our channel to get immediate notification of our videos. Share our videos to your friends and colleagues to create safety awareness. If you have any questions and requirements, please comment in comment box.